Can you just explain to me the thermal bridging here in these traditional types? Just slow it down a little bit for the benefit of people who maybe haven't experienced these before.
Yeah, things with a traditional, what we call a traditional foundation, lots of concrete, lots of brickwork, which is necessary some of the time for structure, but with a passive house, we avoid this where possible. So we have here concrete. All these concrete sections here are in the ground. So this shows a foundation, strip foundation, which is underground. So is that, and the piles. So the idea is that we build on this for structure. So the brickwork goes directly onto the concrete. That concrete is sitting in and on the ground. So it's a massive amount of cold bridge there. So all these areas here is pulling energy or pulling heat out of the build and transferring it directly to the ground. So that ground is actually acting as an absorbance for our heat, our energy at every contact point. Every contact point is a potential cold bridge or thermal bridge.
Excellent. So we've used the word heat sink before, so we've got some heat sinks going on there where you're just sinking all that heat. In this example, because we are talking about retrofit, how do we create a thermal break in the examples here for if you were able to sort of explain that?
Thermal break, when it comes to retrofit and dealing with an existing situation, you could have any one of these. So, you're going to have an effect of thermal bridge there somewhere. All you can do, if you do an external insulation on a retrofit, you dig everything out and you take it all the way down to the foundation. And then what you do is you insulate this floor. You can't dismiss it totally, but what you do is you improve the thermability of it. You won't cancel it out, but you can improve that contact point.
Yeah, so it's quite hard labour.
Yeah,
to dig out that concrete.
Yeah, that's an external insulation. There are advantages of external insulation because it helps with cold bridging and thermal bridging elsewhere in the house. But internal retrofit, you can actually cancel more of this out because you can insulate the floor, insulate the inside of the walls, and create a continuous insulation and helping to compensate for that. So there are advantages and disadvantages to an internal or an external insulation when it comes to retrofit.
Got ya. Do you want to just go to the radon barriers? There you go. John, radon barriers is something that's not always been in existence. Do you know roughly when they did start introducing radon barriers?
Radon gas itself has been pretty much ignored up until the last 10 years or so, 10, 12 years. Even now, traditional construction don't take this into consideration, or very rarely. It's been part of building regs now for a number of years, but it depends on the area because not every area has radon. It's only where you get a lot of granite and stuff in the ground, which is what radiates radon gas. But we always consider that if we have an airtight house, we don't want any gases or anything interfering with that. So what we do is we get to a standard. It's all about construction of building to a standard and keeping that standard across the board. Don't have this there, that there. We keep a standard. And if we protect against damp and we protect it against radon gas as a standard, doesn't matter where we build, we'll always have that standard. So radon gas is a radioactive, natural occurring gas. Nothing we can do about that. It comes from hundreds of meters under the ground, but we can protect against it. We can't prevent it, but we can protect against it.
So we often use the word standard and maintaining standards, and that ties in a little bit with, I'm going to use the word regulation. So how do we ensure that people are using a damp-proof membrane, radon barrier, and doing a thorough job?
Well, I think you've touched on the point there. How do we maintain a standard? You would think that today everybody would show the same amount of detail and want to get to the same standards, which they're supposed to do. But unfortunately, that isn't always inspected, and it isn't always thought about to getting to that point, because regulations change around the country. Not all the regulations are the same. One district may even have a slightly different one to the next district. So it's about surpassing what they all want, getting to a standard so it's 2 or above every standard across the UK, and keeping to it every time, and making sure that when these people come out to inspect this from the local authorities or whatever organisation it is, it's always up to standard. No shortcuts. There must not be shortcuts here. It's got to be done to the correct standard every time.
So I suppose that points to the fact that there will be variances between all the different local authorities, but then those variances will carry through into each individual person that's going to be doing that job, how diligent they are. And that's why we're such advocates of the passive house standard, because everything has to be thoroughly documented. And there's no getting round things.
No, absolutely. I think everything needs to be independently inspected. I believe everything needs to be up to a certain standard, and I think we need to achieve a certain standard throughout the UK and never go below it, because that way we need to keep an eye on our attention to detail. The most important part of any construction is the base. You get the ground right, you get the base right, the rest of the building will be a lot easier and of a better standard itself. It follows through the whole design.
Brilliant. Do you want to just put it onto the section where you talk about keeping things square? That's it. Yeah. Um, John, could you just explain how it is that we make sure things are square, and what sort of tools you might use, and just to be really diligent on that point?
When it comes to keeping the base square and level, everybody uses lasers. I personally don't. I have other things such as, I call it a dumpy level, where I like to look through a lens and make sure that it's level. And believe it or not, I even use a water level on occasion, which is the most accurate level in the world, which is basically a hose pipe with 2 tubes on the end with a measurement. Fill it full of water. It's more accurate than any laser will ever be. But that's besides. The besides is also keeping it square. How do you keep it square? For example, if this screen, we wanted to check it for square, we could do a number of things. We could either measure from corner to corner, transfer it round, measure to corner. If those measurements from corner to corner are the same, you're square. If there's not, then you're out of square, so it can be adjusted to suit. That's the easiest method. Sometimes the area is too big to do that, so you can use a dumpy level or a theodolite, where you can set it up to a center point, take your first line, set the base, turn it exactly 90 degrees, and then check this line and mark it onto your profile. So you can go from profile to profile, and that way you can work your corners out. But easiest way is actually just with a tape measure, if you can do it, if you've got that distance. It's very simple.
Excellent.
When it comes to sub-base, many different versions. Not always do we use a suspended or an insulated raft. Sometimes we actually use a timber frame, but we sit it onto a hollow frame or a hollow base. What we have here is blockwork. We have almost a typical foundation with blockwork. But what we've done is we've suspended T-beams on top of that with timber and a timber plate on the outside. And then when the timber framework went on top and was filled full of insulation, the insulation went down in between, and this whole area from this insulation pad here to there was full of eco-bead. It was a solid mass of insulation all the way through and all the way up. Now, this EPS you see here, the jabalite, the polystyrene, which is underneath. What we've actually done is we've packed that up with a little block of polystyrene underneath in little blocks. That allows for airflow, because the thing to remember with any subbase, if you've got insulation, then you probably need some form of airflow underneath. Okay, so this is a subbase which is halfway through construction, but it's a different version of. But we've still got the insulation there all the way around without the break. Therefore, we're cancelling out any thermal bridges.
Excellent. So you've got that continuous insulation there, and you've also got airflow, which is really important.
That is in this circumstance. Airflow in this circumstance is important, just simply because of the design of the base. When you have a polystyrene EPS base, which is your insulated base, you don't actually need this. This is just to cancel out or help to cancel out any additional thermal bridging, because there are concrete connections.
Got you. Brilliant. Thanks, Joe.